morning aviation weather. Today we're going to be going over the atmosphere, its composition, energy, temperature, how those things are related, as well as the different types of altitude, such as the pressure altitude and density altitude. How does that affect you as a pilot when you're flying?
Okay, so before we go into layers of the atmosphere, we're going to go ahead and talk about the composition. Many gases make up the atmosphere, however, nitrogen and oxygen make up the bulk of that. And it's these molecules being in the air that gives us the ability to fly. If that was void, well, one, we couldn't be alive, but two, we couldn't fly through the air because nothing would be there to give us the lifting force.
The atmosphere is composed of several different layers, and each one is separated by its own pause. We're going to go into each section and just kind of break down where they're at and as far as vertical range, and then what characteristics you can expect from each one. The troposphere begins at the Earth's surface and extends to 36,000 feet. It varies from 3.7 miles at the poles to 11 to 12 miles at the equator. As you go up in altitude, the temperature decreases as there's less particles in the air. All weather occurs within this region. The stratosphere extends from the tropopause to approximately 31 miles above the Earth's surface. As you increase in altitude, the temperature increases due to oxygen in the atmosphere absorbing the sun's radiation, creating ozone. The temperature ranges between negative 56 degrees to negative 3 degrees Celsius, and most commercial traffic is done within the lower region of the stratosphere to avoid the turbulence and weather phenomenon associated with the troposphere. So in this section, I'm going to cover the mesosphere, thermosphere, and exosphere all together. None of our flying is going to take place in these regions unless we start working for NASA. The mesosphere extends from the stratosphere to 53 miles from the Earth. The atmosphere gets thinner in this region, so the radiation that was occurring in the stratosphere isn't effective in warming. So as you increase in altitude, the temperature will decrease. It goes from negative 3 degrees Celsius to approximately negative 100 degrees Celsius. In this area is also where the majority of meteorites burn when you see shooting stars. They're usually in this region. The thermosphere starts from the menopause and extends to approximately 430 miles above the Earth. This area acts as a safety buffer in a way. As the gases are increasingly thin, they're able to absorb the majority of the UV and X-ray radiation from the sun. The temperature reaches as high as 2,000 degrees Celsius at the top of this layer and increases from lower altitude to high altitude. Although the temperatures are very extreme, it's not hot enough to burn our skin because there isn't enough molecules. The exosphere begins at the thermopause and ends at 6,200 miles above the Earth's surface. This layer is where the atoms and molecules in the atmosphere are able to escape into space, as well as satellites orbit the Earth in this region. This is the furthest region of our atmosphere. This has been my presentation on the atmosphere. Feel free to go back and go over sections as needed if you missed something. All of my references come from the Aviation Weather AC006 Bravo. And yeah, feel free to like and subscribe.